In this problem, we are going to plan the synthesis of this compound, which is, let's number the carbons here, 1, 2, 3, 4, 5, 6. So this is 1,2-hexanediol. Hexanediol. All right, and we want to make it from, let's see how many carbons do we have at the beginning. 1, 2, 3, and 4. So it is butyl bromide. Okay, so, and since we already counted the carbon, we know that we have 2 more. Right, so, and again, one strategy that we had used before is using acetylene, the anion, to increase the number of carbons. So I can have this compound react, for example, with this anion. And this will come from, I have acetylene, and I need to put it with sodium amide. Once I have created that anion, I can do an SN2 reaction over this. So the next step, so SN2 here, that will be my leaving group is a bromide, and that way I will be creating, let's do the structure of the compound. So I will have 1, 2, 3, and 4, and then I need to have 1, 2, 3, 4, 5. I will have 2 more. I'm missing 2. 1, 2, 3, 4, 5, and 6. So the 4 that I had initially and that, which means that I have the number of carbons that I need to go there. So what is the reagent that I need to use to make a diol here? So to make diols, here we need to use from diols can be formed from alkenes. And then we do the dihydroxylation. There's a couple of ways. Let me write down here things. If we had an alkene and say that I had that alkane and I treat it with osmium tetroxide, or let's make, I'm going to make it cyclic too, so that is better. I'm going to have just cyclohexene. If I treated that with osmium tetroxide, I will do the cis-diol because the mechanism here is a syn addition. Well, that is a methyl compound. You can have that in the one with the which is on the dashes. But another way of making a diol would be using upper acid. Many cases we use metachloro perbenzoic acid, but any, say, peroxy acid will do. And this is formed via an epoxide, which, that is the epoxide, which under acidic condition is protonated. And then you have the nucleophilic attack by water. That will give you another diol, and in this case, the diol, I'm going to write it in another color so we're not confused because I'm using a smaller space. So here, the diol will have, say, 1 up, and that's not, and the other will be in dashes. So opposite sides. So that is 2 ways in doing that. Here, not as important, but I'm going to be using the metachloroperbenzoic. And I say that because here you have 2 hydrogens, so it's not, we're not going to be seeing that stereochemistry that we have here in the case of the cyclohexane. So let's work on that. But that reaction had happened with an alkene. So I need to do something prior, so I need to transform the alkyne into an alkene. And so what can we do here? We can use hydrogen, and we use Lindlar catalyst. And that way, I will remember this is a poison catalyst. So we will stop at the 1, 2, 3, 4, 5, and then I have that. And so And in this case, I think I have an extra carbon. Let's see. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. Yeah. Okay. So that is the idea. So again, to go from the alkene to the diol, what I need to do is the step with the peroxy acid. So what we're using now is 1 peroxy acid, could be metachloroprobenzoic. So here, NCPA. And you will form first an epoxide here, and then it will open up to a diol, as we see here, as we explained here before. Okay, so in summary, what do we have here? The first step was having the butyl bromide react with the anion. There's an ion coming from the reaction of acetylene and sodium amide. Then we did a hydrogenation with a Poisson catalyst, Lindlar's. And in the third step, what we did is an epoxidation, and we opened the epoxide under acidic conditions, so metachloroprobenzoic acid to do that. So that is, in summary, what we did. And remember that the strategy involved that reaction at the beginning because we had 6 carbons here and only 4 carbons in the substrate. So always check the skeleton when you're planning a synthesis.